All right, we're back. We're still on page 1 of notes 1 of Calc D, which is multivariable calculus. We are talking about 3D stuff, trying to get used to it. So the last problem I tried to emphasize, make sure you're trying things on your calculator. Make sure you're trying them on GeoGebra because we're going to do a lot of that. And if you don't start off on the right foot, by the time you really want to do it, you're going to be so far behind that like you're going to feel overwhelmed. So that's one of the keys to success in this class is like never let it get overwhelming, right? Like as soon as something's a little overwhelming, like pause, review, ask your questions, make sure things make sense to you. So let's see if we can do these. So both of these are going to be about spheres. Spheres, for like whatever reason, are like the easiest surface to deal with. Like you would think it would be a plane, but planes are like weirder maybe than you think. Like coordinate planes and things parallel to the coordinate planes aren't that bad. But once they start tilting, it gets weird, it gets hard to imagine them. A sphere, everybody can imagine a sphere, right? Everybody, like someone has thrown you a ball at some point in your life and you've been like, oh, that's a sphere. So you just have this sense of it. So let's see if we can do this. So what I'll do with this is I'm going to do, I don't know. I mean, I might do it multiple ways. Let's see. Find the center end radius of the sphere that has these as endpoints of diameter. I'm going to find the equation too, because I think it's weird not to. So if these are the endpoints of the diameter, then like what we're kind of, I don't really need to belabor this, but I'm gonna, hold up. So I noticed that I could like, you can change the default fill on shapes that you draw. And so I made it that at some point. Okay, so we have this, and then we just have endpoints of diameter. So nothing fancy. So the center is going to be the midpoint. So that's going to be 5 plus 3 divided by 2, negative 2 plus 4 divided by 2, and 4 minus 12 divided by 2. It's 4 plus negative 12, but whatever. 4, 1, and negative 4. So I believe that's our center. I think the center of a sphere is usually just given as like x0, y0, z0. Like it's hk in 2 dimensions for a circle, but it's like hk what? So x0, y0, z0 I think makes the most sense. Now the radius we can get one of 2 ways. We can either go from the center to either of these points, which is actually what I'm going to do. I'm going to go from the center to here because it looks like it has the smallest numbers involved. Or we could have done from here to here, which is the diameter, and then divide by 2. Doesn't make a difference. So I'm going to say that it is the square root of 5 minus 4 squared, negative 2 minus 1 squared. I perpetually make my radicals too short. 4 minus negative 4, so 4 plus 4 squared. So this is the square root of 1 plus 9 plus 64. So 70, radical 74. So then that's what we were asked to find. I'm also going to find the equation. So it's x minus 4 squared plus y minus 1 squared plus z plus 4 squared equals, don't forget to square your radius. That's, textbook mistake. Okay, I think that's all the stuff that we know about this. Excuse me. So what I'm going to do is I'm actually going to do the next problem, and then I'm going to do this over again on a calculator, and then I'm also going to do it on GeoGebra, and then this I will also do just on the calculator, probably not on GeoGebra, because I don't think we're going to like learn it. Well, actually, I don't know. We'll see. So let's do this one first. Describe the surface whose equation is given by this. This is just completing the square problem. So rearrange it, x squared plus 10x, leave a little gap, plus y squared plus 4y, leave a little gap, plus z squared plus 2z, leave a little gap, equals, move the constant over, so the constant is 19. All right, let's complete the square. So divide by 2, square it, add it to both sides. So plus 25, plus 25. Divide by 2, square it, that's plus 4, add it to both sides. Divide by 2, square it, add it to both sides. Plus 1, plus 1. All right, and then Each of these will be a perfect square trinomial if you have done this right, which hopefully. So we'll get x plus 5 squared plus y plus 2 squared plus z plus 1 squared is 20, 45, 49. So the center, so it's a sphere with a center of -5, 2, nope, -2, -1, and a radius. Remember, 49 is the radius squared, so 7. All right, so what are we going to do? We're going to go back, do this on the calculator, do that on GeoGebra, do this on the calculator. So I'll probably just do that on the calculator while I'm there. All right, so if you're like 100% confident in everything that we've done, you know, feel free to move on to the next video or move on with your life or whatever. But I'm going to do this. So, all right, I'm going to put a new problem, doc for enter calculator. I'm going to store these points as A and B. So A as vectors. So 5, -2, 4. B is always store your points as vectors. It lets you do all kinds of stuff with them. So for the center, right? So let's say I'm going to call it, I'll call it center. That's going to be A plus B divided by 2, right? The midpoint. So we get 4, 1, -4. All right, the radius. I'm going to use the norm. So that's menu 7, 7, enter. Menu 7, 7, enter. So we can do center minus A. Get that? We could have done center minus B. We could have done, what could we have done? We could have done the norm of B minus A and then divided that by 2. Any of those get us the radius that we're looking for. Okay. While I'm here, I'm going to do the other one. So to do the other one, I'm just going to complete the square. So menu 3, option 5. So know how to use your calculator, because your calculator is like an amazing tool for learning this stuff. Like I did learn it before these calculators were a common thing. And my understanding of this material just like skyrocketed when I could start actually playing around. And I didn't have to do everything by hand, right? So like if you're curious, you can just make the calculator do the work. It's so annoying when you have to do it by hand. All right, we're gonna do comma x because we want to complete the square on x, comma y because we want to complete the square on y, and comma z because we want to complete the square on z. And we get that. All right, and that is in fact what we got. So good. All right, so now what I'm going to do, I'm going to go over to GeoGebra. I'm going to use GeoGebra Classic. I'm going to turn on 3D. I'm going to turn off the 2D thing. I really should have a way of doing this automatically. I don't know what I'd have to bookmark or something to like make that happen. So click here, turn on 3D. Now go over here. We can kind of drag this over, click and close this. There are other ways that you can do that. This is just the way that I do it all the time. All right, so what I want to do, I think I'm going to plot the 2 points, 5, -2, 4, and also 3, 4, -12. So I have a plan. What I'm going to do is I'm going to plot the points. Okay, I'm going to plot the center, which I think is 4, 1, -4. And then just kind of look and see, like, is that the midpoint? Yeah, that definitely looks like the midpoint. All right. Now what I'm going to do is I'm actually going to plot what I got. So x minus 4 squared. And you can watch it like tries to guess the surface that you're graphing. And it's like just weird. There, it's like, okay. It seems to default to z being like the independent thing in the event that it's like got to guess. Squared equals 74. Okay, so here we go. You might want to turn off the XY plane. So 2-finger click or right click or however you do that and just uncheck plane. There you go. I think that worked out really nicely. I think maybe, let's see if there's a sphere command. There is sphere, point, radius, or point, point. Okay, so point, point. I have to, I don't know if point, point is probably, I don't know, what's A, B. It's not that. So it's like the center is the first thing that you put. So the center for me is actually C, and then the radius is the square root of 74. So that's just, again, multiple ways. You got to know multiple ways of doing things so you can check them, or like sometimes one is easier than the other. It's almost always easier to use like a built-in thing than to type in your equation, but like who knows? All right, so I'm gonna go back to the notes. As the end of page 1, a lot of review stuff, a lot of like getting our feet wet with GeoGebra and remembering how to use the calculator. But there you go. So that's some sphere stuff. Spheres are the easiest of the surfaces because they're just circles with an extra dimension, you know? Like, I mean, in a lot of ways, planes are just lines with another dimension, but like it's a little weirder because probably honestly, because you do more stuff with lines, so it just feels weirder. But there you go. Tons of background. I'll be back in the next video, and we're just going to keep going. So I hope to see you there.